So hello, I just had to check if the recording was started. Hello, my name is Toby, and in the last couple of days, or maybe even actually weeks, um, I've talked to a few people online about um, our thoughts on programming at the university level. Like not very specifically, but it came up several times, and so I had a bit of back and forth to some people. And given that I work at a university, I thought I'd make a video about my thoughts on programming courses and also like if I would have a programming course, how I would teach it and what I would teach. So a little bit to me, I've studied computer science and media, it was called, at a University of Applied Science in Germany. So University of Applied Science is kind of I don't know, like university, but more practical. So you actually learn, like several of the courses actually have to do with programming, which is kind of different to like real university, where oftentimes, at least I think so, where oftentimes you have a very theoretical view on programming. And like sometimes you even just have electives where you can learn to program, but like other than that, there's no real programming in your course. So compared to that, University of Applied Science, you do a lot of programming actually, which is quite nice because in my opinion, programming is a practical thing. I mean, you can do all the theoretical stuff if you want to, but if you actually want to learn to code, um, the University of Applied Science is way nicer, I think. So I've studied at the University of Applied Science, Computer Science and Media, and made my like bachelor's and master's degree there. And now I work at the different University of Applied Science, again in Germany. This times, however, computer science and business. So they're not quite comparable, but in general, both of the courses are computer science and la la la. So they're not 100% computer science, just partially. Um, so the only thing I can really say today is kind of from my experience as a student or as now someone who works at university, and maybe it is completely different to other people. Um, so, however, if I would have a lecture or a course at university, this is how I would do it. So I want to start with the how part because I think the what part will be more controversial. So I put that like later in the video. So let's start. Um, I don't know how. And for that, um, I want to talk a little bit about how my experience studying computer science was. So in general, I think I had three different kinds of lectures, or actually three different kinds of courses, since maybe all of the lectures in one course have been the same way. So I think there are kind of three types of how you do it. So the first one is like I don't know, like the typical, oops, typical, the typical one. What's a typical lecture? Well, there's someone standing in the front and he's talking and talking and talking and talking and talking and talking and talking, and then everyone goes home again. Um, well, sometimes there is a bit of interaction. Most of the times, however, that interaction is something like, "Oh, sorry, can you say that again? I didn't really listen." And then the professor or lecturer or whatever will just talk about the thing he just said again. So I say that's like the typical um, lecture, how you would imagine lectures, like at school or at university. So then there's the second one, which is kind of a practice module. So practice. So you have your, I don't know, programming 101 course, or your database course, or your algorithms course, or whatever. And you actually have um, one time slot, which probably is somewhere around 1.5 hours. You get some tasks, and you're now supposed to do those tasks, which is of course useful, because I don't know, like obviously you learn by doing. It is like the whole learning by doing thing is obviously um, a thing. So the practice parts are quite nice, but in general you just get a few tasks, and maybe you can ask the professor for help. Maybe they're even students from higher semesters, and you can ask them for help as well. And sometimes they actually will answer you. And yeah, that's kind of the second type of lecture I had. Oops. Then there's the third type, which is kind of the um, whole semester project. So semester project. So here, you kind of, I don't know, at the beginning of the semester, either you choose some sort of project or you get assigned a project, and then you have all of the semester to program something, and then afterwards you hand it in, and someone will look at the program and will say, hey, the program is cool, or well, this is super bad. And they might actually even look at your code and again say, hey, your code is super cool, or your code is super ugly. Maybe you have to do a presentation about your stuff. That might be a part of it. Um, Maybe it's like a single person project or with many people. Um, Maybe you, like during the whole semester, don't talk to a professor at all, or maybe you talk to someone like every week. Um, there's different flavors of it, I would say, but in general, you do a semester long project and have to program something. And what all these three kind of have in common is, well, that the first one, I mean, there's one guy talking to you, and he gives you some, or she, I don't know, they give you some insights on programming. Either they teach you a language or a specific thing, like databases or I don't know, web stuff, or design patterns or something. Um, so this is what you do here. In the practice part, again, well, you do some practicing, but in general, you do it on your own, or maybe you do it with a partner. But um, if you do it alone or with a partner, in general, that means you as unexperienced person or unexperienced persons are trying to do something. And in the third one, that's the same thing. So no matter if it's a one-person project or a 20-person project, um, and also no matter if you're actually talking to a professor every week or you don't do it at all, in general, you as a beginner programmer do the whole project. And all this stuff I feel is lacking something, which is kind of obvious if you think about it, at least in my opinion. And it is almost never done. I had exactly one course in that type, and I will write it down here. I'm doing like a little separation. For is like watching an expert. This is almost never done. Like I said, I had it in one course at the master's degree, where basically the course was I watched the lecturer, he was an external guy from a company. He came every Friday evening or Friday afternoon, probably. Um, and we watched him implement a Lisp compiler, so Lisp, the programming language, or actually Scheme, which is kind of a nicer version of Lisp. We watched him implementing a Scheme interpreter, not compiler, interpreter, and that was the course. And it was amazing. And that was the only course where we ever did that. So actually, the whole semester, we came every week, or probably every second week, because I wasn't there always. But in general, we came in every week and we watched the guy programming stuff. And in every other craft that you kind of learn, this seems obvious. So, and like if you want to learn an instrument, or if you want to make, I don't know, if you want to learn sewing or carpentry or whatever, cooking, a big part of your education is watching someone else do their stuff and they will explain, hey, this is what I'm doing, and you pick like stuff up from them, and then I don't know, you will learn that by watching the experts. And in programming education or university programming education, I don't know why that doesn't really exist, because it was super valuable and it was super cool. And so if I would do a course, this was the original topic of the the video. Um, I would do the following thing. Wait, I can't live with such a not straight line. So here it is. Okay, so how would I do it? How would I do it? How this is probably too long. How would I do it? So obviously, each of those things um, has benefits and like positives and negatives. So how would I do it? Um, I would actually put all of those in to some degree. So first of all, I would split each week into 3 different parts. So first of all, I would make a video that is like 1 lecture long of category 1 and 4. So it's like typical in a way that I would just say a lot of stuff, like the info dump lesson. Somehow I obviously have to teach the students some stuff, like either about programming languages or about, well, the thing we want to do. And however, it's also a mixture of 4, because I would also program in that video. So like actually implementing the stuff I am talking about. What I forgot to mention is, um, just like in the cool course I had at university, um, what you would do in the course would be one project starting at the beginning of the semester, ending at the end of the semester. So every week we will add something to our project, and I will talk about the theory of that, of whatever we're doing, and then I would implement parts of it in the video. And why a video? Like I said, the typical university lecture where someone is standing at the front and is just talking and talking and talking. I don't know if you think your course doesn't really have interactions, then why not make it a video? I mean, people can just rewatch it, or they can watch it at any day and at any time they want. They can maybe, if they think the topic is really easy this time, they can speed the video up to watch it faster or just watch slower at the parts they're interested in, and the ones that they already know, they just kind of skip. It's, I feel, way nicer for the students if you just give them the info, and they can consume it in the way they want. Obviously, they have to watch the video, so you shouldn't make the mistake of kind of when you're live at the university, you shouldn't make the mistake to talk about the video because then they will not watch it. So you really have to, okay, I just assume you've watched the video. Maybe if you have one or two questions, you can ask them now, but in general, the video is over now. So that would be part one of the lecture. Then there's the live part, which is kind of a 4 plus. So again, it's the watching the expert part. What did I write? Watching in expert. Oh my god. Watching in expert. Oh, maybe I wanted to write watching unexpert. Oh no, do I have to record the video now again? Watching unexpert. So I hope that was clear. It's watching unexpert, not watching inexpert. What did I do there? This doesn't even make sense in German. I don't know what I wanted to write. So back to here. The second part is live. So live at university, or at the moment probably live online. It is watching an expert. So again, I would program something, probably a continuation of the stuff I started in the video. However, I really would try to include the students into this process. So a lot of asking, hey, what would you do, and all those things. Um, what I would even try out, although I'm not sure if it's that nice. For example, Visual Studio Code, which is the IDE I'm using for programming, has a live share mode, which is kind of like Google Docs. So you can just share your program and a lot of people can work in it at the same time. Um, which isn't quite the thing you want in the course, but maybe you share it with your students, you program a bit, and then you say, okay, now someone else can try it, and then you just give them the controls over your project, and they can try around a bit. I don't know if that would work. I would try it out. But in general, I would talk a lot to the students. Hey, how could we do that stuff? So that part obviously is a bit slower or quite slower than the programming part in the video. So that's why there's this mix. Like in the video, you can get a lot of stuff done. Um, and in the live part, when actually trying to talk to the students, you're obviously programming a bit slower. And so you need both of them kind of. And then obviously the practice part. I mean that's still live. I don't know. Live and at home. I don't know. Live plus at home. That's a plus. Live plus at home. Practice. So again, part two is practice. So probably directly after the live part, with the live coding and stuff, um, you make a practice part. I mean, this is basically like the normal practice parts are. You give them some tasks and they should implement them. And obviously, if they don't finish, they can finish their stuff at home. However, what is very important here, those tasks should also be part of the project you're working on. So if you're programming something, then you started in the video, you all uh, like expanded in the live part, and then the students expanded as their assignment task. Or not really assignment. Assignment would mean I graded, which I do not want to do. Um, but they continue the project. What you would probably have to do is you have to actually give them solutions, because if they don't figure it out, I mean, you need the solutions to continue with um, the whole project. So you kind of have to give them the solutions. Probably again as a video. Um, Also, what I think is important, please encourage group work here. Um, I mean, this is not really what you're going to do when you later on in your life work, although some companies have pair programming, that is weird. Um, but in general, you obviously will work alone, but in the student setting, in the university setting, just say them, well, they can work with their buddies, and probably it's way easier for them if they can exchange their ideas, especially as beginners. So this is how I would do it. So one thing is missing here. This is number 3, and this is not really what I want to do. Wait, let me just make a straight line again. Um, So the last part of the lecture, or the last part of the course, so this is kind of the structure of one lecture. And the last part of the course is obviously grading. So how do you grade? Um, and again, I kind of want to make the connection to like real crafts, like again, like carpentry, like sewing, like whatever music stuff. What would you do? Well, you have some sort of practical assignment. Um, so not a real semester-wide oh my God, assignment with one or with two S. I don't know. I don't know. Assignment. This looks wrong. Assignment. I don't know. So maybe you know how to write it. Should have Googled that beforehand. Like that there is still room for another S if it's necessary. Um, can I? I cannot pause the recording to Google that. Well, you have to live with it. So a practical assignment, and like not a semester project, but like 1 to 2 weeks. Um, plus, wait, no, the plus belongs in this line. Plus, um, oral explanation. Explanation. So you get like 1 or 2 weeks to implement something, maybe even on top of the project you did during the course. You have like 1 or 2 weeks time so that it's not too big of a thing, but still enough to make some cool stuff. I'm still wondering about the assignment. Oh no. So 1 to 2 weeks, and at the end you also have to explain all your code, so the oral explanation that I actually know you did it and not someone else did it. And this might even include something like, hey, couldn't have you done this instead? And then maybe they will actually tell you, oh yes, I thought about that instead, but I even tried it out and it didn't work. Oh, I don't know, I thought it was stupid. Maybe that's true. Um, or you could even say, hey, couldn't you change this thing to that thing? And then maybe they go like, oh, I didn't think about that. And well, think about it now. And then they have to actually think about it. So again, that kind of only works if they actually did the assignment, even if it's written with 2S. And I'm still not sure. And I will have to Google that now. Otherwise, I can't sleep at night anymore. Assignment. It's with 2S. I knew it. Assignment. assignment. So I knew it. Okay, this is how I would teach. I'm not sure, shall I delete that now or shall I save it? Let me save that. No, that's not where I want to go. Put it here. Um, Programming course. Okay. Oh no, I wanted to call it programming course how. Save programming course underscore how. I don't know why I save it. And now I save what. So if I would have not oops. Can I just probably not? No, I cannot. Sorry, this is kind of like cleaning the blackboard or the whiteboard in this case. So now the how, no, now the what part. So what, I don't know, maybe I just what. So the what part might be more controversial, so that's why I put it at the end. Oh my God, we're already at 26 minutes. Okay, stay with me. In half an hour, I have to sit in oral exams, so the video will be less than half an hour now. Okay, so here's what I would teach. I mean, spoilers, as I said, I studied at a computer science and media course, and maybe you can figure out what I want to do. Okay, however, there's a reason why I would do what I will want to offer. What I will offer, I don't know. So there's kind of three things you learn as a student. There's the tools. Tools. So what are the tools as a programmer? Well, programming languages. And not really programming languages, but programming language paradigms. So what does exist in that area? There's very obviously object-oriented programming. I mean, I don't really have to talk about object-oriented programming, I guess, but the idea is everything you do is an object. And you have classes and you have inheritance and all that stuff. And then class variables and like member variables and stuff like that. Then there is functional programming. Functional programming. So functional programming is a kind of more mathematical way. The idea is kind of that you don't really have state, so you don't have variables really. You kind of calculate everything on the fly, which sometimes sounds nice from a theoretical standpoint, and you sometimes even do stuff like that in your algorithms course. For example, I did it in my algorithms course. Um, but in general, if you actually want to have a full project, functional programming is oftentimes very slow because, as I said, you try to calculate everything. It's very, I don't know the word, not error prone. It's very difficult to make errors in it. Because everything is kind of an expression. Um, well, always stuff in programming are expressions, but like is like a mathematical term. You're calculating something. So it is really cool. I would say it's kind of a niche thing, although probably people who do functional programming will punch me for that. But I would say it's kind of a niche thing because if you do it like full 100% functional, your program would be really slow. And I'm not talking like opening an empty Word document slow, which takes like 20 seconds, but like really slow. So that's functional programming. Then there's other ones like logical programming, or you can even like, I don't know if it's exactly the same thing. Again, I don't have too much experience here. And again, maybe people in that field will punch me for like combining those two, and they say, well, those are two very different things. I don't know. Um, which is logical programming, or also like constraint solvers. So imagine a Sudoku. You have the rules for Sudokus, right? You have to put the numbers 1 to 9 in each column and line, and in each 3 by 3 square. And now you give your program a Sudoku, like a started Sudoku, and it will have to fill it out given the rules it has. This is really nice for proofs and stuff, but I don't really see how you can write like a normal program in it. So, and there's one other big thing. So the first one is kind of huge. The other ones are not that big. And then there's procedural programming. So here you don't have objects. You mostly have procedures or functions, or what the object-oriented world would call methods, although methods kind of need a class, but like the C world would call it functions. Procedures is actually the correct thing because not all of them will return a value, which is the mathematical definition of a function. But in general, you have functions or procedures or however you want to call it, and you put some data in it, like some parameters, and it will calculate stuff. Maybe this is actually how you started learning at university. Maybe you had a, I don't know, a C course or a Python course, and you didn't have objects in there. And then in the second semester, you did the real programming, in big quotes, real, and then did the real stuff with object-oriented programming, which I think is nonsense, but that will have to wait for another few minutes. Also, the procedural programming, some people call it DOD, which is data-oriented design. I don't know. I think it just exists to have another 3-letter um, expression, like OOP now have DOD. I don't know. So again, data-oriented design. You don't have objects. You kind of focus on the fact that you have data and you put the data into procedures. Um, so the problem I see with that is at the moment, um, universities kind of focus on that. Like the amount of circles I put around it is like how important it is at university. And I do understand from a, I don't know, economical standpoint or business standpoint, I don't know, that you want to teach your students the stuff that is used in the industry. This makes a lot of sense. Um, Many corporations or companies um, work in the object-oriented way, or they program object-orientedly. Mm. And that's why that is the thing you're teaching. Um, However, sometimes, like I said, maybe in your algorithms course, you have the functional part, maybe not. I had it there, and again, I had the cool Lisp interpreter course. Well, we didn't really do much in Lisp or Scheme, but um, I had it nonetheless. And then, I don't know, I do the procedural since probably, um, like I said, maybe you had a C or Python course at the beginning of your study. So like in the first semester, where you did like procedural programming. And again, I see this as a problem. While I do understand why universities focus heavily on object-oriented programming, I think it's kind of bad that you only mostly teach one way of doing things, because like having a choice of how you do stuff is always really helpful. And if you have a project or like a problem, and it would be easier to solve in another way, in a different way than object-oriented programming, but you just never really have learned about it, then you still have to do the object-oriented way. So again, you kind of learn one tool and you might look at other tools. Like you only learn how to use a hammer and then you say like, look, there's a screwdriver, but we don't use it here. So, this doesn't really help you. Um, you will never use it because you never learned how to use it. And so I think one should actually look at one of those more, especially procedural programming, because like this is the other big one in my opinion. The other ones are not too big. Procedural programming is very big, um, I would say. And again, this has a bigger circle here than the functional one, but really because I only think in the first semester maybe you did some stuff in it. Um, again, before you did the real object-oriented stuff. Um, okay, continue. The second part is okay, I really have to hurry up. I only have 24 minutes left. I don't know. Level of abstraction. This is a weird one. Level of abstraction, but an important one. So if you go to real university, so the one with um, the heavy theoretical part, you do a lot of theoretical stuff, and that's okay. However, if you call yourself a programmer, so at University of Applied Science, you have to apply your programming stuff. And like more specifically, your programming is applied to a computer. And so you kind of can think of a computer as like 100% hardware. So this is if you actually think about, I don't know, eye opens and they having current and like the current is going up or down or stuff like that, or about I don't know how like the problems you have at the level of USB cables or Wi-Fi signal and stuff. You can think of your computer as that, or you can think like 100%, I don't know, Turing machine, like the super theoretical stuff. And this is the level of abstraction, or these are the levels of abstraction you can have when thinking about a computer, and obviously normally you're somewhere in between there. So here would be like 50-50, 50-50. And the thing is, if you only learn object-oriented programming, which we have just established is kind of the case, you will also always kind of have the same view on computers. So for example, in object-oriented programming, they will tell you, for like the typical Java example is if you write a program and you want to have a list, like you want to have a list T, so like a generic list, you use the interface list, and then later on you can kind of choose between the array list, which is kind of like an array, or the linked list. Again, I have to hurry up. Oh my God, 20 minutes. Or the linked list. And those function differently, and your algorithms course, your algorithm data structures course will probably tell you like the O notation of how they differ. But in general, object-oriented programming will tell you, well, you can just say list, and later on you can use the one or you can use the other one. Um, so you're kind of still thinking of it very abstractly. Actually changing those will not change the logic of your program. It will work exactly the same, but the performance of your program will be different. And that is true. So what I would say is like the way you work in university is mostly somewhere here. Again, mostly due to the fact um, that you're programming in an object-oriented way, and this is how object-oriented programming looks at your problems. It's not 100% theoretical, because if you're 100% theoretical, you actually don't really care about the performance, because if it's just theoretical, you don't really have to think about the time it takes. Like you just have to say, hey, this works or this doesn't. Like the halting problem or something. Like not decidable, done. Um, Again, also you get told those different things of array lists and linked lists so that you can choose the faster one. So you do care a bit how your computer actually works, but mostly you don't. And again, maybe, well, no, I used this kind of blue. Maybe some of the courses are a bit more hardware oriented, maybe databases and stuff, or maybe um, like artificial intelligence stuff, that like neural networks, while you don't really implement them or something, neural networks care heavily, obviously, about their hardware performance, and they run on GPUs normally to be faster. And maybe, like I said, you have your algorithms and data structures course, or your theoretical informatics course, where you learn about the Turing machine, and everything that is Turing complete is like as powerful as the Turing machine and not more powerful, because like that's the full level of powerfulness there is, and you learn about the Chomsky hierarchy and stuff. And so you're kind of operating in this area. Again, I think that's kind of a problem if you only think of your computer in one specific way. There's this whole way where you could actually think about your computer as a very hardware machine, where you actually think about um, like really think about if something is slow or fast. And so this is also something I would teach. I would like be somewhere on this side of the 50-50 line, probably, or at least at the 50-50 line, but not in the area every other course is in. Okay, as I said, I have to hurry up, which is kind of nice for you if you're actually watching this. Otherwise, I would be here for a very long time. The next one is skills. So I actually don't know why I put the other stuff in quotes. I just put it in quotes as well, skills. So there's kind of three skills when it comes to programming. There's program structure. So how do I structure my program? Program structure. And what do I learn at university? Well, you obviously do it in an object-oriented way. You use your cool design patterns by, I don't know, the Gang of Four or some other ones, design patterns. You follow the solid principle And obviously you have to write clean code, whatever that actually means. Clean code. Again, those are not really things you choose, like they are kind of just additions, like extensions. You write your stuff object oriented, sorry, and you write this stuff object oriented, and then you specify the object oriented by using specific patterns. Um, well, the solid principle is also kind of a pattern, and clean code also follows in that thing. You don't really learn alternatives. It's kind of just okay. Object-oriented program is like a very loose thing, and if you use some of the others, it just gets more specified how you're actually doing it. But again, it's not really that you have a choice. It's kind of you have a choice kind of in how much you follow the principles, but not really in different principles. Um, so then there's the other one, which is algorithmic thinking. How do I go about a problem? This looks really ugly, but I just hope you can read it. How do I go about um, solving a given problem? So imagine you have to do something, you have like some constraints, and you now have to, I don't know, calculate some stuff together and then rotate it in a 3D space. I don't know. How do I go about solving such a thing? Well, you don't learn it at university at all. Besides your practice lessons. So I mean, I could write practice lessons. I don't write it. So you don't really learn that at all. I feel, which is also very difficult to actually teach. So how do I teach a person how to think? I don't know. That's very difficult. Um, but you don't really learn it. What you learn in your algorithms course are specific algorithms to solve specific problems, like sorting. Like here are 5 different sorting algorithms, or here is how you solve. No, I wanted to say how to solve the traveling salesman problem. That's not really possible. Here is how, I don't know, you do A-star pathfinding. Those are, again, algorithms for specific problems, but in general, um, you want to know how I can solve the problem I have. Which is not what you learn in the algorithms course. You learn solutions to problems of other people, basically. Again, this is very difficult to teach. I do understand that. Um, but in general, you don't really learn that. And then there's the third one is um, hmm, I am coping with errors. So I specifically didn't want to say error handling because like that sounds like exception handling or something. Coping with errors slash bugs. Sorry. So obviously, when you're programming, you will make mistakes and you have to fix those mistakes. So how does university prepare you for that? Well, obviously, if you just use object-oriented programming and the garbage collector, and I don't know, you do clean code and solid clean code, um, you don't have problems. Oh no, wait, I forgot one. You're doing exceptions. Um, Obviously, if you follow those, you don't have that many problems. If you use a garbage collector, you don't have memory leaks, and if you do all those other things, it's very easy um, to not make mistakes, which I can't really comment on if that is actually true. Even if it is true, sometimes you have errors and you really have to fix them. And so what you will learn is this is a debugger. This is literally what you learn. This is a debugger. I will show you 5 minutes of how you use a debugger, figure out like how to usefully use it yourself. Um, so again, going back to the analogy of other stuff, um, here's a piano. Look, this is how you make a sound. Figure out how you play it yourself. Um, so those are kind of the skills you learn. And again, this is a bit sad. So, how do you fix all those things? So first of all, you should actually realize that these are actual problems, which probably many people will not agree with here, or several people will not agree with me here, because most people, um, do like the object-oriented stuff. And I don't even want to say it's super bad. It's just that it's one way of doing things. And so what I would like to do, good. Um, so what I would like to do um, is again, I would kind of want to fix all those things, or not really fix, but more like mitigate it. Like fixing would need a big change. Mitigating is easier by, for example, having one course where you do it differently. So some of the things here of the skills part, um, we can already fix with the way how I said I would do a course. If I do a course, the way I would do it with the watching unexpert, not inexpert, watching unexpert part, that expert would first of all talk about how he or she or they think about their problem. And by that, you would at least watch others how they solve problems. I mean, it's kind of cheating because the lecturer probably has prepared the stuff for the course, so they don't have to think a lot about it anymore. But in general, you still get some explanations on how they're doing it. And again, especially in the interaction with the students parts, you will probably have bugs and you will make mistakes, and like you, the expert, um, and then you will actually have to find those bugs, and the students will watch you while doing so. This might seem boring and uninteresting, but again, watching someone who is experienced doing something is always very useful, I think. And even if that means watching someone trying to find the bug. Um, Maybe they have a cool technique. How they do debugging, um, with commenting out stuff or doing debug print logs or having a specific whatever secret way of doing things. Watching them makes you actually like learn stuff they're doing. So again, we are fixing kind of the things here. Mitigating, sorry, not fixing. Um, so other than that, I haven't really talked about what I would actually teach. So what I would teach myself, again, I said I studied computer science and media, which also means I studied game development. And since I'm only working like half time on university, so I work like 20 hours a week at university, the other 20 hours a week, or probably more like 10 hours a week, to be honest, um, I'm working on games. And this is what I'm doing. And obviously, this is what I want to teach people. But here's the thing, it's actually reasonable to say that. So why would I do that? And now I have 5 minutes left. Why would I do that? First of all, can I use green? I don't know. First of all, I would do the programming in C. So the language C, which is a very important language in my opinion, because every device will have a possibility to run C, as has every programming language. Every programming language basically has a way to call C code and interact with it, um, like in the form of DLL, like dynamic link libraries. You're always able to talk to C, so actually learning C on its own is a cool skill, but um, it means you will have to program in a procedural way, which is very cool. So now, why do I want to program a game? Well, a game means you have to update your game like 30 or maybe even 60 times a second, and times a second. This is only possible, well, if you don't use a graphics card, which you obviously wouldn't do in the course. Um, this is only possible if you actually think a bit uh, about how your computer works. So, for example, if you have like a traditional game where you have a huge game and then like this part is the thing you see on your screen, if you try to render, like draw, if you're not into gaming, if you try to draw all this stuff, this will not be possible. Like your computer is not that fast, and you at least have to think a bit about the stuff you're doing. This might uh, include not doing super useless stuff like drawing stuff outside of your screen. Um, this might even mean having stuff correctly, whatever that means, in memory so that you're actually accessing it in a useful way. Um, Again, a game is super nice for that because you have a necessity to update. You have a necessity that your program runs kind of fast in order to update it a lot of times per second. That's why I actually think programming a game in C is really a useful thing you can do at university. And then again, given that you're programming in C, um, you will not do any of those. Like no, no. Um, well, also you won't do any of those. No. Um, and in general, you can do quite a lot of things differently. So like the whole idea of the course, wait, I have to make the X bigger so it covers the clean code as well. Um, a lot of things you can do here. Um, wait, I just lost what I wanted to say. Sorry. Um, right. What I wanted to say is, um, in general, this whole course would be a question what you have learned so far course. So you use a different type of programming language. You use a different way of looking at your computer. You use a different way of structuring your program. So the way I normally program is very non-clean codey way. I have a lot of structs in one file. So struct is kind of the C-like equivalent of a class. I have a lot of structs in one file. I have few but very long functions. And so again, this is kind of the, hey, this is all super different um, to, 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 to what you normally learn. And I will all do that in this course. Again, for one reason, because that's how I do it. And obviously I want to do what I'm doing and I want to teach others the stuff I'm doing. But really, also as a question the stuff you've learned. And maybe people will learn, hey, the stuff this dude is doing is super wrong. I stick to object-oriented programming. That would be a very valuable lesson. But on the other side, there's like, oh, this dude is doing something very different, and it's also cool, and maybe it's even cooler. I don't know. Um, the students will have to figure out if they like it or not. But it would be a very different insight on the whole field of programming, and I think that would be really nice for the students. Now I have to stop the recording because I have to go to the oral exams. Maybe I come back afterwards and show you a little thing I have prepared. Um, but for now, bye. So hello. Um, I'm back, just like the Terminator. Oh God. Um, so the first student had internet issues and had to leave again, and now there's a gap because the second student um, already like canceled their exam a few days ago. I think they are sick. I'm not quite sure. However, that means I now have another half an hour, and I probably will need way less than that. So I have talked about what I would do and how I would do it, or how I would teach it and what I would teach. And in the last 1 or 2 weeks, probably, well, the last few days I didn't do anything, and before that it was like a week. Um, I started programming something which is an example of what I would do in such a course. Um, so what you will see now is roughly after 4 weeks into the semester. So a third, I would say, of the semester, maybe a bit less, maybe a bit more, depending on how fast or slow the students are. What I haven't said before, like obviously not everyone is interested in games programming. Not everyone wants to have an actual choice in what they can do and use. So this would obviously be some sort of um, elective course, and therefore it's probably scheduled rather to the end of your university life, or at least at the end of your undergraduate course. Um, so I don't know, in like where I work now, it would be probably around the sixth semester. Where I studied before, it would be somewhere between the fourth and seventh, because we had a lot more um, electives there, and therefore you could have put it more to the front, more to the back, which of course is a bit more difficult because the experience levels of the students is quite a bit different. However, so again, this is what I have prepared. So what I have done, I have taken a game from 1998, which is called Knights and Merchants. It's a German game, like written by 1 or 2 people, plus 4 people making the music and sound, I think. And I took the sprites, like the images of that thing, and used it here. So I mean, you can basically acquire those for like $5 online, or if you like me, have the original thing on a CD somewhere lying around. Um, so oh no, this is no, this is not possible. Wait, um, there's a bug on either Windows or somewhere else where you can't move a thing from one screen to another. Um, so maybe before I show you the thing, given that C is kind of platform dependent and not independent like many other programming languages, um, okay, given that it's platform dependent, you kind of have to have a little layer for like supporting the different platforms. I did that with a thing called SDL, which is kind of exactly for that, for writing games on different platforms. This is like the only library I used here and I will use here. in the course, and it's only used so you're able to work on the different operating systems. However, for some reason, I'm not sure if it's their bug or Windows bug. Um, if I start a program with that and move it from one screen to another, I don't know, it messes something up and it doesn't really work. Oh, I think I already compiled. So here it is. Let me first press pause. No, hello. It was again weird. Okay, so it's actually, wait, I just want to show you that it's actually not a problem with different screens. If you have two screens open and you move the window, it gets bigger and then it ignores my mouse. Um, Again, this is, I think, the problem of the underlying thing and not my programming problem. Um, so that's a bit unfortunate, but that's not our fault. So here is what I have programmed. As you see, all those cool sprites here are obviously not drawn by me, but are taken from that game. Um, and again, that means you can kind of get all these sprites for like $5, which is not different than buying a book in school that you have to read. So what you see at the moment with this white square at my mouse is kind of like a level editor. I mean, this is a very game specific thing. Having a level editor is probably not something used in other programs, but I don't know, I cannot draw stuff. So like the crane stuff is street. Then there's obviously green, which is grass, and which at the moment isn't used. There's also stone, which at the moment also isn't used. And like the pink stuff here is at the moment undefined. I can't undefine it again. I can make it grass though. What is very important, if I now close the thing and open it, obviously what I have just done is saved, so it's serialized and deserialized. Oh no, I moved the window again. It is serialized and deserialized, which has been done in like week 2, together with the level editor. What was then done later on in the third lecture was loading all those bitmaps. So that is actually a custom data format from the game. So they have one file where they store like the different colors that are used in the images, and then they store the actual images separately in like 4 different files. There are a total of 10,000 images, and you load them all out. And yeah, the reading of that has been done in like lecture 3 or something. And then also what has happened. So if we wait a little bit, those people will start moving. Here now they all walk around, and that has been done in like lecture 3. So obviously people moving around and drawing animations again is not something you do in your typical business, enterprise, whatever area. So it's kind of useless in that sense, but um, well, you at least solved some problem. Okay, however, there are also useful things. So what I will, or what you see here, obviously, is what has been done in lecture 4. The people are moving around and they're using the streets for doing that. And this has obviously been broken as well. So there's another guy here on the top left. Ignore that he has no hands or arms. That's due to how the animations have been drawn. But if I now click somewhere here, you will see he will move towards it. And if I press something like F8, you actually see, wait, let me just pause. Um, you will see in black um, the different positions that the pathfinding algorithm has looked at. And the brighter it gets, the further you are away from the goal, and red kind of meaning you are very far away. And since all those things have not been checked, they're kind of infinitely far away. That's why they are in red. I should have probably color coded that differently. Um, no, I wanted to keep that, but we'll continue the pause. And so what this thing is doing here is I think is a, well, no, I know that it's a star. I said I think it's a star because maybe I've made a bug. Um, but yes, this is like the A star pathfinding algorithm. Although I'm not sure if that should actually move to the right. If I'm, hmm. No, it looks correct. I would have to really check if I didn't make a mistake probably, but in general I think it should like everything here should be correct. Um, right. Pathfinding, for example, is something you could or you might use later on in your business world, because I don't know, maybe you have trucks moving around, like I don't know, logistic stuff, or maybe in a warehouse you have to move around robots or whatever. Um, those things are actually useful, and here they are kind of done in, like I said again, in the environment of a game. So it's kind of probably fun actually doing that. And but as I said, it might even be a useful skill to have later. So if you watch all those other guys, they are moving around from house to house and take out these resources and bring them to the storehouse. At the moment, they're very stupid. Um, so as soon as a house has like, as soon as this house, this is the first house they check, as soon as this house has um, produced a timber, they will all move towards it, and the first one who arrives gets the timber out, and everyone else is just going in there as well, realizing, oh wait, there wasn't anything to do here, and then they will move to the second house on their list, which is this house. And the same thing basically happens. So not everyone who goes here actually has something to do, and then some of them will go to the first house again. Um, this will be mitigated in the next theoretical lecture, where you would then write a job system. So um, so if like the house says, hey, I produced something, uh, then one guy will figure out, oh, okay, there's a job now, the job of, hey, please take out that resource. And he will say, okay, I will do that job, and everyone else will know this job is taken and they will not do it. Again, a job system is something you probably might even use in your later company life, because again, that's kind of something useful. Um, Again, maybe you're in some sort of logistic thing, but also in other areas. Um, Such a job system sounds actually like a cool thing and is probably useful. And well, there's all sorts of other stuff you can do here. And like I said before, this is like a third of the semester, maybe even less than that. So what will be added is of course more live, like more game stuff, which again is not that useful in your later life probably. Like there will actually be people producing the stuff, so like there will be a carpenter in here who uses stuff, and there will be tree trunks, so there's like a lumberjack and he will cut trees, and the trees will have to be brought to the house, and then the carpenter will turn trees into timber and all that stuff. So you have like this whole production cycle. Which, but again, like again, this is something if you work in logistics, is probably a really useful thing. Um, Other stuff will be added, like a very little version of a GUI system, which will probably work differently, like the GUIs, so the normal GUIs object-oriented people use, so-called retained mode GUIs, where you create classes and then you wait for callbacks and stuff, which will probably not be as it's done here. This will probably be an immediate mode GUI, how it is called, which is kind of a different way of writing GUIs. Again, the whole question what you have learned until as of now thing is still going on here. Um, then for the hardware view, which I have talked about before, um, the drawing will be important, like the performance of the drawing will actually be kind of important if you want to scale it up. If you probably realize this is a very big screen, it's 3440 times 1440 pixels. And if I would actually scale the thing up, I probably wouldn't be able to draw it. So it won't be like super insane optimization, but at least not doing useless stuff. This is like the level of um, the level of optimization we will probably do here. Then for realizing if we are slow or not, probably a little profiler will be written, which is not a very difficult thing to do. What else? Like there's so many things you can do here. Some of them are more or less useful in your later life, probably, but I mean, all of them are kind of solving a problem you have at hand, building a big project, watching someone else building a project, um, expanding on the project with your other student friends. And so in general, I think it's really cool. Also, I mean, just now after those 4 weeks, I mean, I'm already having so much fun just watching the dudes moving around. I assume it is a lot more motivating doing that than, I don't know, writing book data to a database and then reading author data from that database out again and doing stuff with it. That's probably a lot less interesting than doing something like that, even if you don't really use it. Like the actual game related knowledge in your life, I still think you can take a lot out of this. Um, Am I missing something? Well, I don't know, but like I said before, there probably will be a lot of debugging in here because bugs will happen. And yeah, we will, again, I said we will write a profiler and a very tiny GUI system probably. Maybe we will also write some sort of, well, that will be kind of part of the profiler, but some sort of visualizing data, which is always nice also in your later life, visualizing data, so like a graph or something. Um, so creating a graph from stuff you do in your program for debugging purposes or for performance purposes or whatever purposes, this is probably also a nice thing to do. And yeah, other than that, um, I told you now what I've done until yet, as of yet, I don't know. And a few things that I would expand upon, and there's still some lessons left, so there's still some cool things you can do. Um, I don't know, like if you're going full crazy, you maybe want to incorporate networking into here so you can um, play the game at one point with someone else. Oh, I forgot at all, like actually interacting with the game. At the moment, I can only move around this one guy. which is something you actually can't do in the game. Um, Unless later if you have armies and they are fighting and stuff, but like the normal people you cannot command around. And so you kind of have to have another way of interacting with the game, which also will be added. So there's a lot of stuff that will be added here. And given that some of the stuff is programmed by me or would be programmed by me or by whatever lecturer, I mean, someone else can do such a course as well. Maybe it will look different. But given that someone is like some experienced guy is doing programming work or is doing part of the programming work, like the program is actually moving forwards in quite a considerable rate compared to what a student might achieve. So after those 4 weeks, I'm at something like 1,400 lines of code, 1,300 maybe. Um, as I said before, I do have really long functions, and this is exactly how I want to program. And like if you look at the update method, that's like the update function, that's like 600 lines of code. Um, this is how I program. Again, as I said before, this is quite different than the clean code you normally learn, where like the full creative thing I sometimes hear is like, oh, you're only allowed to have like 10 lines of code per function or per method. Otherwise, you should split it. And again, like this course is kind of a question everything you learned, um, where I show, hey, you can also do it differently. And then people will say, well, hey, cool, you can do it differently. Or they will say, no, this dude is weird. Why does he do that? That's not how you do it. And again, like I said before, that would be a valuable lesson if you realize there's other ways and you don't have those other ways. Um, that's kind of a nice thing to do, but at least you have now learned that there are other ways. And that might even tell you that the way you are doing it, like the original object-oriented way, you like better, and like that's actually strengthening your experience with object-oriented programming, that you realize, hey, this is way cooler than those other guys writing spaghetti code, which I do not think this is, but I mean, I don't know. So this is what I wanted to show you. I wanted to talk about how I would um, teach something. I would tell you, I wanted to see what I would teach, and then here's kind of like a specific example of the stuff. This doesn't mean this is like the only way how you can do it. Maybe if you really hate games, you're doing something else. You're doing a more business-like, like if you take the stuff I did here, maybe you can put it to a more business setting, um, where you have, I don't know, cars and trucks driving around and taking resources from A to B. I mean, that's kind of the same thing. And yeah, I think I've been talking now for way too long. I think, oh my God, I think together it was like 1.5 hours. Um, so if you've actually been watching this, I'm very thankful. And maybe you want to write a comment and comment on the stuff I'm saying. Maybe you liked it. Maybe you say I'm completely bonkers. I don't know, but just say it. So yeah, oh, also, one of the stuff here is like, I said 1,400 lines of code, but like here's 100 lines of just setting some values where we just looked at the images and just say, okay, this animation starts at this frame and all those things. I think that's it for it. And again, thank you for watching. Maybe write some comments. Maybe tell me that you hate what I've said. An object-oriented way is the only thing everyone has ever to learn, and watching someone else programming is a waste of time. I don't know, maybe if you want to say that, then tell me that. But um, I don't know. I would be happy for discussions. Not that I really think many people will watch this, especially not till the very end. But um, I don't know. So maybe there will be at one point a follow-up video where I will talk about the course I have now actually done, if that will actually ever happen. For now, this is like a um, wishful thinking. Maybe um, I will be allowed at one point to do such a course. Maybe not, I don't know. But this is like how I would do it and my reasoning for it.